something hitting our eyes is not a good idea. So we must ensure that nothing hits our eyes, correct? So that is the desire of us, that we should be safe from any. খুব ঘুম পাচ্ছে? Sure?
Yeah.
You can have a good night's sleep. Actually speaking, I sleep quite a lot, and most of the time I sleep when I am studying. It is so interesting, isn't it? Or is it so boring? So let's make it interesting. If you feel asleep, you can, stand up a little, do some little jogging in the classroom, no problem. Yeah, that will be quite interesting. Your fellow students can see you dancing and may enjoy it a bit. So no objection if you dance. So that is it. Desired value is there, correct? Means in our brain some input is given already that something hitting our eyes is dangerous. So it should not. That is the desired value. The measured value, your eye is something that can meter. Yes? That can calculate. Right? That can measure the danger that is coming towards you. Right? So that is measured value. Your eye sees the object coming towards you. And you see, this dB and MV then compares with each other. So the object is not coming towards you, rather it is going towards you. You are not going to retaliate. Agreed? So when you see that dB and MV is very close, yes, and that can be, you can require the immediate action. And what did you do? You closed your eyes, or you shifted your head away from the line of the projectile. So that is your corrective action. So we must say, before our human civilization started, before that only the control system was there. And what we human beings have done is basically worked this one to facilitate our industry or machinery works. That same sense, nothing extraordinary. আমরা ছোটবেলায় অটোমেটিক, আরে বাবা এটা অটোমেটিক, সাংঘাতিক কিছু মনে করতাম, রাইট? যখন আমরা এটা স্টাডি করি তখন দেখি যে ইট ইজ সো বেসিক্যালি, তাই না? একদম ঘরের কাছে। Only thing is that we have never thought about it that way, but it is something like that. And now we will see how these three variables are interacting in our control system. There will be a few features in it. Best is to know them, and what are the proper places, we must know about that too. So this is the diagram you will find in the RITS general book, and let's get acquainted with it first before I enter some more components in it. Obviously, these are, bellows, correct? Bellows is something has to be having a cylindrical shape, one end fixed, but they are flexible. So whenever the air pressure increases, the free end is expanding, and when it is reduces, is retracting. So there is a linear motion for air pressure on the bellows free end. And there are some 1, 2, 3, 4, 5 bellows there, you can see, in a control system, correct? And each one of them has a different name. So this one is called an MV bellow. This one is a DV bellow. The black one here is a PAB, proportional action bellow. And the green one here is derivative action bellow, and the blue one here is the integral action bellow. So they are having 5 different names. Don't miss them out, okay? MV bellow, DV bellow, and black one is proportional action bellow. The green one is derivative action bellow, and the blue one is integral action bellow. Okay? The function of them are quite similar, same, you may say. Whenever the pressure of air inside the bellow is changing, the effective length or the free end of the bellow is going left or going right, or expanding or retracting. Okay? So that's it. In here, this is a strip made up of some material which is very light and corrosion free, and it doesn't deflect easily. It's a hard substance that is never corroded, and that has got a flat surface. It doesn't expand due to heat also. Agreed? Okay? This is called a flapper. A flapper is a kind of a strip, like a lamina. Lamina is something that has got length and breadth but no height or depth, correct? So it will be a very thin strip of substance, flat. It must not be, flexing under the forces. মানে বেকাতেরা হবে না, flexing that is called. Okay? It must not be corroded. It must not be expanding too much due to thermal changes. Yes? Having a very low coefficient of thermal expansion. Right? Corrosion free. Why? Because any change in its size and shape can jeopardize the entire control system. So it's kind of an ebonite জাতীয় জিনিস, or stainless steel. বুঝতে পেরেছো? Yes? Okay. And these blue lines can be of similar material, but they don't need to be flat. They can be round. Yeah, like a shaft. Shaft বলতে আমি আবার propeller শাফটের মতো সাইজ বলতেছি না. Yes, kind of a needle type of thickness here. Okay, again very light and should not flex and should not corrode. That characteristic must be there. All right. Next comes in the question is this fellow here, and you already know the name of it. Is nozzle. Nozzle basically, there is a air pipeline connected to its back, and nozzle's end is open basically. So there is a hole there, and the size of this hole is 0.7 of a millimeter diameter. So you can understand if darts dust of 1 millimeter diameter enters it, of course cannot enter it, it will be arrested before then that means the nozzle can be choked and your entire system kaput. You understand? That's why the air that you require for control system needs to be very, very clean. Understand? Right. And what we can do with these blue figures, again some screw and stud and those are kind of arrangement by which we can thread and unthread and the nozzle can go up or down. Mind you, the distance from the flapper to nozzle tip remains the same. It doesn't change. It can only go up and down parallel to the flapper. So distance between the flapper and nozzle remains the same while we adjust the nozzle's position vertically. Understand that? Yes. Good. These two are small capsule-sized air bubbles. Okay? Sometimes in your book it is written capacity tank. Sometimes in electrical system we use capacitors doing the same job, which basically stores energy. Yes, it doesn't eat energy. It just stores charges and discharges.